Hello, welcome to this lesson on the laws of exponents with Miss Silverstein. We are going to learn how to raise a power to a power, as well as how to deal with exponential numbers when the exponent is 0. To get started, let's recall that 2 cubed is 8. However, what happens if we raise 2 cubed to a power? What would happen if we raise 2 cubed to the second power? This is still an exponential number. Now, our base is 2 cubed and our exponent is 2. Before, 2 was our base and 3 was our exponent. Remember, 2 cubed is 2 times 2 times 2, or 8. Therefore, let's do the same. 2 is telling our base of 2 cubed to multiply by itself twice. 2 cubed times 2 cubed. We know 2 cubed is 8. So let's simplify our 2 cubed to 8. And 8 times 8 is 64. Let's continue with examples of raising a power to a power in order to derive a rule for such a case. 2 squared raised to the 2. Our base is 2 squared, our exponent is 2. So we are going to multiply our base of 2 squared twice. Two squared is 4. So we have 4 times 4, or 16. Let's do the same in our second example. 4 squared raised to the 4. Our base is 4 squared, our exponent is 4. We know that 4 squared can be simplified to 16. So we have 16 in each of these 4 squares. We are replacing 4 squared with 16. And as we can see, this is a tedious problem, which is why having a simple rule for raising an exponent to an exponent comes in handy. And 16 times 16 times 16 times 16 is 65,536. Let's look to see if there is a pattern. Going back to the previous page. 2 cubed raised to the second power was 64. If we were to take 3 and 2 and multiply them, we would get 2 to the 6th power. 2 to the 6th power is 64. And 64 is the answer here. If we were to take 2 and 2 and multiply them, we would have 2 to the 4th power. And 2 to the 4th power is 16. Again, there is a match. And lastly, if we are to take 2 and 4 and multiply them to 8, 4 to the 8th power is 65,536. We have derived our rule. When raising an exponent to an exponent, keep the base and multiply the exponents. Let's try some examples. 3 squared raised to the 2nd power. We multiply our exponents and get 4. So our problem is 3 to the 4. The answer in exponential form is 3 to the 4. In standard form, however, 3 to the 4th is 81. Let's try the second example. 3 raised to the 0 power raised to the 2nd power. 0 times 2 is 0. So in exponential form, 3 to the 0 power is our solution. However, if we wanted to express 3 to the 0 power in standard form, we do not know how to do that at this point. So let's review how to raise a base to an exponent of 0 and come back to this problem. Raising a base to an exponent of 0. We have not seen this yet, but we will understand how to do this. In order to derive how to raise a number or a base to an exponent of 0, we are going to look at this example. This is a problem that we reviewed in lesson 1, dividing exponential numbers with a common base. We are going to apply that here and more. Now, 2 cubed divided by 2 cubed can be expanded to 2 times 2 times 2 in both the numerator and denominator. However, another way to solve this problem is to apply the rule of division. The bases are the same, so we keep the base of 2, and our exponent is the subtraction of the exponents. 3 minus 3 is 0. We will use the top expression to find out what 2 to the 0 power is. Right away, we see that all of the 2's can cancel. This 2 cancels with this 2, giving us 1. This 2 cancels with this 2, resulting in 1. And these two 2's cancel together, also resulting in 1. Remember, there are multiplication signs, and 1 times 1 times 1 is 1. Because these are equivalent, 2 to the 0 power is 1. Therefore, going back to our previous example, 3 raised to the 0 power is 1. Any base raised to an exponent of 0 is 1, always. Now let's try these last examples. At this point, you can pause the video and revisit it after you have tried these 3 examples, or follow along. 5 to the 0 power is 1. Any number raised to the 0 power is 1. Negative 5 raised to the 0 power is 1. We have not dealt with a negative number at this point. However, the entire negative number, negative 5 in its entirety, is raised to 0. Therefore, it's 1. Unlike the last example. Whenever a number is being raised to the 0 power, or any exponent, The number that is closest to 0, or that exponent, is the base. Therefore, negative 5 is not raised to the 0 power. Negative 5 can be seen in two parts. 5 is being raised to the 0 power, and negative 1 is being multiplied by that result. We can write this as negative 1 times 5 raised to the 0 power. 5 to the 0 power we know is 1, and 1 times negative 1 is negative 1. Therefore, negative 5 raised to the 0 power in the second example is 1 because of the parentheses. The parentheses tells the reader that everything is being raised to 0. And when everything is raised to 0, the answer has to be 1. But without these parentheses, only the number or the base closest to 0 is being raised to 0. The negative in front is not being raised to 0. It looks like this. Thank you so much for watching this video. You can always re-watch the video and pause it at your convenience. Until next time, this is Miss Silverstein, and have a great day.